Hi, NA Physics, it's Mr. Neff. Today we're going to talk about sound intensity level and decibels. Before we do, why can you never trust a train? I'll tell you at the end of the video. Last video we talked about some intensities, and we came up with some intensities on one of the examples of 51 watts per square meter and 29 watts per square meter. My question to you is this a loud sound or is it a soft sound? I mean, you might say, well, the threshold of hearing is really small, so maybe it's pretty loud. But at the same time, it's just a fraction less than 1, so maybe it's not. And so my question here is this a loud sound, maybe the intensity of 0.51 watts per square meter, loud or not that loud? Now we know from another video that we can hear sounds that are a frequency of 20 to 20,000 hertz. Frequencies anywhere in that range. And that's pretty amazing. It's a thousand times difference. But if you think about intensities, we can hear intensities anywhere from 10 to the minus 12 watts per square meter all the way up to 10 to the 7.4 watts per square meter. And you think about how many times bigger that 10 to the 7.4 is compared to the 10 to the minus 12, that makes this range of frequencies look like nothing. So we've got these unbelievable range of intensities. And so we can hear 10 to the minus 12, we can hear 10 to the minus 11, we can hear 10 to the minus 10, and so on and so forth, 0, and we can't go that far here, so maybe I just say 1, 2, and so forth, and up to 7.4. Now look what I did here. I didn't write the 10 to the every time, I just wrote the exponents. And so I'm starting to refer to these sounds just by their exponents. And I've gone into the realm of logarithms. Logarithms are this idea of referring to a number as its exponent. So now, that's the start of the idea. Now, humans said, well, since this is the softest sound we could hear, we should start calling that 0. This little bit louder sound, we're going to call it 1 unit of exponent different, 2 units of exponent different, 12 units of exponent, 13, 14, and so on and so forth, like this. I'm referring to a sound based on its exponent, and I'm calling the louder sounds a higher number and calling the softer sounds a lower number, and 0 is as low as you can get. Well, the quantity that I've just invented, or I've just talked about with you, I didn't really invent it, is this sound intensity level, referring to these sounds with these numbers. And what unit are these numbers in? Well, new quantity, new unit. And we're calling these bells, named after Alexander Graham Bell, the inventor of the telephone. Now, it turns out that those bells are pretty large. And so it was more convenient to use tenths of those, or decibels. And so it's common to talk about decibels, and I guarantee you've heard of decibels before, maybe didn't even put together that bells and decibels were related to each other. Now, if I want to relate those two ideas of sound intensity in watts per square meter and sound intensity level in decibels, how do those relate to each other? Well, say I had two sounds. Say I had a sound that was a louder sound and it had an intensity of I. And I say I had a quieter sound and it had an intensity of I naught. How many decibels above the I naught is the I sound? Well, this equation will tell you. This says that the decibel level of the louder sound above the softer sound is equal to 10 decibels times the logarithm of this quotient. The intensity of the louder sound, usually it's the louder sound, I should say. It's possible to do this in a different way too. But for us, let's say that it's the louder sound, and here it's the softer sound. And so this is going to tell you how many decibels above the softer sound is the louder sound. Because of that, it's really a comparison. And so you don't usually see this in books, but I often like to explain this with the delta in front of here, saying If we're going from the softer sound to the louder sound, how many decibels above? Okay, we're going to try an example of that, but let's see how this works conceptually first. You're going to see tons of charts like this. No matter what book you're looking at, website, video, you're always going to see a chart that relates different sounds with their intensity and their intensity level, and then their perceived loudness. The threshold of hearing, we've talked before, as 1 times 10 to the minus 12. It has an intensity level of 0. Now, rustling leaves from this example has an intensity that's 10 times more. You can see I have 1 times 10 to the minus 12, 1 times 10 to the minus 11. It's 10 times more. The intensity level of that, the decibels, 10 decibels more. And so where some people get goofed up on this is we're multiplying by 10 and we're adding 10. And that's that logarithm idea again. Every time you multiply the intensity by 10, you add 10 decibels. And so for this whisper, 10 to the minus 10, well, it's 10 times as intense and it's 10 decibels higher, and so it's going to be a 20. Now, you could see that with inside of a car in city traffic, it's 10 to the minus 4. So let's think about that. That's a 10 to the 6th times as intense. So that's going to be 60 decibels higher. And so I'm multiplying by 10 to the 6th. And so I'm going to add 60 decibels and get down to 80. I know I skipped that normal conversation for now. Now, the car muffler is 100 times as intense, and so it is 20 decibels higher. Okay. Now, what about that normal conversation? It was not a nice, easy amount of intensity difference. How do we handle that? Well, what's the factor that you have to multiply 1 times 10 to the minus 10 by to get 3.2 times 10 to the minus 6? Well, what number do you have to multiply 1.0 times 10 to the minus 10 to get 3.2 times 10 to the minus 6? If you divide those two numbers on your calculator, you're going to see that it's 32,000 or 10 to the 4.5. Now, if I multiplied by 10 to the 4.5, then that means I have to add on 45 decibels from where I started from. I'm comparing from the whisper, so I'm going to add on 45 decibels, and I'm going to get 65. There we go. Now, one last thing before I do go. You'll see this neat chart that I found online, and it shows you a neat thing. And it shows you that if you change the decibel level by 10, and that causes the intensity itself to go up by a factor of 10, so multiplying by 10 and adding 10 on the intensity level are synonymous, and we just talked about that. But then they talk about there's a loudness gain factor. Now, if you can remember, loudness was the subjective opinion of how loud the sound was. And so if I played two sounds for you and I said, here's the first sound, here's the second sound. The second sound's louder, right? You'd say, yeah, of course it's louder. And I would say, how many times louder is it? Now, without a microphone, without computer software, you wouldn't be able to say the 10 times. You only have your ear. And the ironic thing is your ear only thinks that the 10 times as intense sound is only twice as loud. And so all that is to say that whenever I go up by an intensity of a factor of 10, that adds 10 decibels, but all that really does in terms of loudness is doubles it. So your opinion of that sound would say it's twice as loud. And to me, that's scary because that says that you think it's twice as loud, but it's actually 10 times as harmful to your hearing. And so if we went up by 10 more decibels, you would see that we would get another factor of 2 or 4 times the original loudness, and you could continue on this way like that. Let's talk about an example or two here. And here I have an example of a woman standing a distance D from a loud motor, which is putting sound out in all directions. It says that the intensity of her position is a comfortable 7.2 times 10 to the minus 3 watts per square meter. And it says there's no reflection, so that we don't have sounds adding on top of each other, no interference. At a position twice as far from the motor, what are the sound intensity and what are the sound intensity level? So when you see a question like A and it doesn't say the word level, you know that they want an answer in watts per square meter. But if you see a question like B and they ask for that word level, it's going to be an answer in decibels. Now, there's a ton of different ways to ask for that same answer. They could have asked part B as what's the sound level, or what's the intensity level, or what's the decibel level, or the sound intensity level the way they say it here. But when you see that word level, you know they want decibels. So now part A. Here's where the motor is, and here's where she is in the start. And then she's going to go to a place that's twice as far from the motor. And so here she is there. Now this intensity they gave us as that spot. What's the intensity out here? Well, it's going to be a lot less. She's part of a way larger circle now, way larger sphere. And so it's going to be way less intense out there. How much intense? Well, the intensity here was the power divided by the area, or the power divided by 4 pi r squared. Well, the intensity here is the same thing, the same calculation anyway, but since she has twice the distance from it, you can see that this intensity 2 is going to be 1/4 of what the intensity 1 was. And so I'll say the intensity out here was the 3.2 times 10 to the minus 3 watts per square meter, and I'll divide that by 4. That will give me 0.8 times 10 to the minus 3 watts per square meter. Now, what about part B for the sound intensity level? They want to know how many decibels above the threshold of hearing this sound is that she hears out in this position. Okay, well, the change in sound level is going to be 10 decibels, log base 10. The intensity that we're calculating the level for divided by the intensity of the sound we're comparing it to. And so this is just simply 10 times the log of this 0.8 times 10 to the minus 3 divided by 1 times 10 to the minus 12, both in watts per square meter. If I go ahead and run that through, I'm going to see that that's 89 decibels. Hey, just in passing, I want to point something out. Can you calculate what the sound level would be for the closer spot? Now, you know it's going to be more than 89. Take a second, pause the video, and try to do that calculation. Hey, as you just calculated, you did for this spot, change in sound level, 10 log base 10 I over I naught, the sound that we're calculating the sound level for, numerator, sound we're comparing it to, denominator. If you go ahead and run that through, putting a 3.2 times 10 to the minus 3 in that numerator, you end up getting 95 decibels. I can see I'm getting close to my end of my time here, so I'm going to finish up the last 2 things I have to say on the second video. Stay tuned for that.